Okay, so this is problem page 223. We're looking at the list, and we put our data into list 1, list 2. So this is list 1, list 2. So this is a scatter plot. Our correlation was a strong moderate. Now we're going to go back and we're going to graph, instead of list 1 versus list 2, because all of our lists were the same, we're going to do list 1 versus list 3. So I'm going to change that to 3. So now remember, all of these data points, all of these data sets had the same correlation roughly, and the same A in the same slope. So, and I'm going to do a zoom 9.
Which button did you press to get that again?
I hit second y equals. So second y equals, and then you hit enter, and you're going to pick you'll scroll down and pick the first one, and then you'll change your to list. And remember, to change lists, you do second and the number. So like second 1, second 3.
Okay.
And then if I hit zoom 9, well, the correlation was about the same, but our graph is a scatter plot, but our graph is clearly nonlinear. You can see the nonlinear pattern. So correlation in this context we should not use it. Even though it's strong, moderate. Who is making you laugh, Alexa? I can see you. I can see you.
My mom.
Okay. So we talked about it. So you guys, when you look at correlation, we had 4 sets of data, and they all came out roughly the same. So, but when we go to graph them, now it's telling us that whole picture, right? Remember, we haven't even looked at residual plots yet. These are just scatter plots. So this was list 1 versus list 3. So now what we're going to do is we're going to go back, and we are going to do, I want to say, list 1 and list 3, list 1 and list 4. So second y equals, and this time we're gonna scroll down and we're going to do list 4. So again, so far all the data sets we had the same explanatory values, different response values. And we're going to zoom 9. Okay, so if you look at this one, right? What do you think our correlation should be? What is really throwing our correlation off this time?
An outlier.
That outlier, right? And this shows you right here, and we'll talk about this. This point right here, this is the best plot to show you it's an outlier, but this particular point, and we're going to talk about, I think we'll talk about it today or tomorrow, is called an influential point, because it's influencing the slope and that correlation. Because if we took it out, most likely our correlation would be around 0.99, right? You notice that it won't be perfect because something's going on right there. We do need to analyze that gap. But again, you guys, that point right there is called an influential point because it's influencing the slope and the correlation. Okay? So it really comes, the reason I do this data set is because I really truly believe that this hits home why you can't just say, oh, it's looking at a correlation and saying it's strong moderate. Because we've had 4 different types of data sets, and they've given us 4 different graphs. Even though they gave us all the same data, like same A, B, and R. So finally, we're going to do our last one, second y equals. And this time our graph is going to be list 5, so second 5, and then second 6. So this is the very last set of data. And this one was peculiar because this is the only one that had a different explanatory variable. And we're going to do a zoom 9. Okay, so again, you can see there's an influential point. Do you guys see how that just that point, that one point influenced our correlation to make it a strong, a moderately strong linear relationship. And even though it is a linear line, because it is a line, it's not your typical line. So that would not have a correlation because all the data points are the same. All the explanatory variables are the same. And you obviously knew. Like when you put in the 19, you're like, in your mind, you should say, oh, this is really going to affect it. And what would happen if we took that data point out? Well, why don't we see? Well, we can see, right? You're just going to have a line. You're just going to have a horizontal line. That's not a horizontal line. I know what a horizontal line is. It would be a vertical line. So in a vertical line, what is the slope of a vertical line?
0. Undefined.
Undefined. So that's gonna change some things. So again, that's two really good data points that we saw that are influential. They're influencing the correlation and that slope. And if we took them out, our slope would change, our correlation would change. And then when our second data set, we really looked at curved data, nonlinear data that we couldn't use correlation. So the only true one that our data set went with was that first data set and data set A. Okay? So again, if you're ever asked, does correlation give a clear picture of what you need? Of what you need, and you should say no, because you really need to look at that graph, because now we had 4 sets of data and it changed every time. And now you know what an influential point is, so yay for us. Okay, so we are in the blue book on page 230, problem 3.50, and what we're going to do is we are going to find the equation of the least squares regression line using these 5 values: x bar, y bar, s of x, s of y, and r. So let's get started, shall we? Okay, so we're going to use our handy dandy formula sheet. So again, page 230, problem 3.50, and now we're going to use all of this good stuff right here. So we can't find our A and our B until we find our B. So we're going to find our B first. So here we go. So B is known as our slope. And our R is what in this problem? So 0.6337. And now, and you guys, if you think about slope, right? It is the change of y over the change of x. So how do we find, oh my gosh, talking too fast. So it's the standard deviation of y over the standard deviation of what? X. So what is the standard deviation of y? Okay. And the standard deviation of x? 13.17. Okay, so let's figure out what our b is. Remember, you guys divide and then multiply. Slope. Now we can find our A, correct? Because now we have our y bar, our x, and our x bar, and we know our B. So now what we're going to do is we're going to look at this one. We're going to plug in, we have our y, which is our y bar. We don't know our A, we just found our B, and now we know our x bar. Now, I will tell you that because we rounded this right now, it won't be as good as if we plugged in a longer number in for slope, because we've already started, once you round and you plug in, you're starting that round off error. So our y bar is 7.447. We're looking for A plus our B, our slope is 0.1010, and we're going to multiply it by, now, boy, do I write crooked. And it's multiplied by our x bar, which our x bar is 108.9. So again, you guys, it would probably be better if we didn't round the slope right away, but for all practical purposes and plugging in, you probably don't want to do that. You want to round, so we'll continue. So I got 7.447 equals A plus 10.9989. And then of course we subtract because we're just solving an equation. Right, it was 10.9989, correct? Okay, so now I have my slope and my A is my y-intercept. This is a good question that they will give you on the AP Stats exam because they don't have to give you a list, and they're seeing a couple things. Do you know about round off error? Do you know how to plug? Do you know what it's supposed to be, what it's supposed to look like? Can you use your formula sheet? All that stuff. Okay, sometimes they just want that. Now, here's the key though. Once you go to write your least squares regression line, you have to put it in context of the problem. Again, if you do not put it in context of the problem for this part, you will go from an E to a P instantly. Okay, so I don't even know what the problem's asking. The problem is asking about IQ and GPA. Okay, so it says IQ and school GPA. Plot school grade point average against IQ score for 78 7th grade students. Calculation shows that the mean and standard deviation of IQ scores are in the correlation. And it says find the least squares regression line for predicting GPA from IQ. So we are predicting what? So when we go to write this, you can write the hat over GPA. Then we would write our y-intercept plus our slope. And what are we predicting from? What's our explanatory variable? It is IQ. So along with this equation, they're going to ask you a couple of things. They're going to ask you, what does the y-intercept mean in context of this problem? What does slope mean? Or, they would probably say interpret the slope. So those are things you have to think of. So what does our y-intercept mean? This right here. What do you guys think?
When IQ equals 0, they have a negative 3.5519 GPA.
Exactly. When you have an IQ of 0, your GPA would be negative 3.5519. No, it's not. You really can't have a GPA. First of all, GPAs are never negative. And can you have an IQ of 0? No. So in this problem right now, right, the y-intercept does not make sense. And sometimes that happens. Okay, but let's interpret the slope in context of the problem. As GPA increases by 0.1010, your IQ increases by 1. There's a whole bunch of different ways to say it, as long as you can put that the 0.1010 increase is with GPA and that the IQ increases by 1. You guys remember that the slope always goes with GP, like this number always goes with your response variable, and your explanatory variable always increases by 1. Okay. How do you guys feel about finding the slope from those 5 different things?